There are places on Earth where nature doesn't simply challenge you, it erases you. In the autumn of 1930, one of those places claimed another life. Somewhere on the Greenland ice sheet, a 50-year-old scientist disappeared into a storm so fierce that the horizon vanished. Months later, searchers found his body buried beneath the snow, carefully wrapped by the companion who had tried to save him. At the time, most people knew him as a meteorologist. Many scientists knew him as the man behind an impossible idea. An idea so controversial that it was dismissed, mocked, and treated as little more than scientific fantasy. He claimed the continents themselves had once been joined together and had slowly drifted apart over millions of years. Today, that idea forms the foundation of modern Earth science. His name was Alfred Wegener. This is the story of the man who moved the Earth. Alfred Lothar Wegener was born in Berlin on the 1st of November, 1880. His father was a theologian and teacher who directed an orphanage for disadvantaged children. It was a life of discipline, education, and quiet service. Not the sort of upbringing that usually produced Arctic explorers. Yet from an early age, Alfred was drawn beyond the world he could touch. He looked upward. The stars fascinated him. So did the invisible forces that shaped the atmosphere around them. While many scientists spent their careers studying the Earth beneath their feet, Wegener became interested in the sky above their heads. He studied astronomy at universities in Berlin, Heidelberg, and Innsbruck, earning his doctorate in 1905. By all appearances, his future seemed clear, an academic life spent in observatories measuring distant worlds. Instead, he made an unexpected turn. The new science of meteorology was beginning to transform how people understood weather and climate. To Wegener, it offered something astronomy could not, the chance to leave the lecture hall and explore the unknown firsthand. In 1906, he joined the Danish Greenland expedition. It would be his first journey into the Arctic. It would also change the course of his life. For nearly 2 years, Wegener and his fellow explorers lived on one of the harshest landscapes on Earth. They launched weather balloons into skies no aircraft had ever crossed, measured temperatures that could freeze exposed skin within minutes, and traveled across an ice sheet that stretched farther than the eye could see. The Arctic demanded patience. It rewarded careful observation. And it taught Wegener a lesson that would shape everything that followed. Nature did not care what people believed. It only cared what was true. Greenland was not simply a place Alfred Wegener visited. It was a place that changed the way he saw the planet. During his first expedition in 1906, he studied the movement of air above the ice sheet, collecting data in conditions where survival depended on preparation and precision. The Arctic was unforgiving. The cold damaged equipment, buried camps beneath snow, and turned ordinary mistakes into life-threatening decisions. But Wegener was fascinated by it. The ice was not empty. It was a record. Every layer contained clues about Earth's past, about climates that had changed, landscapes that had disappeared, and a planet far more dynamic than most people imagined. After returning from Greenland, Wegener continued his research. He became a respected meteorologist, married Elsa Köppen in 1913, and built a career studying Earth's atmosphere. But then, in 1910, he noticed something that would redirect his entire life. While looking at a map of the world, he saw something that seemed almost impossible to ignore. The eastern coast of South America appeared to fit against the western coast of Africa, like two pieces of a broken object. At first, it was only an observation. But to Wegener, it raised a question. What if the continents had not always been where they were? What if they had moved? At the time, almost no one in science considered that possibility seriously. Continents were believed to be permanent features of the Earth, fixed, unmoving, and locked in place. But Wegener began searching for evidence. He looked at fossils found on opposite sides of the Atlantic. He studied mountain ranges that seemed to continue across oceans. He examined ancient climates preserved in rocks. Again and again, the clues pointed toward the same conclusion. The continents were not separate pieces that had always existed apart. They were fragments of something much larger, a world that had once been whole. Wegener called that ancient supercontinent Pangaea. And in 1912, he presented an idea that would make him one of the most controversial scientists on Earth. The continents move. Millions of years ago, he argued, they had been joined in a single enormous landmass and had slowly drifted apart. He called it continental drift. But Wegener had a problem. He had evidence that the continents had moved. He couldn't explain how. What force could move something as massive as a continent? To geologists of his time, that missing mechanism was enough to reject the entire theory. And Wegener had another disadvantage. He was a meteorologist, not a geologist. To his critics, he was an outsider, telling geologists how the Earth worked. Then came the First World War. Wegener was wounded twice on the Western Front. During his recovery, he returned to the problem. In 1915, he published The Origin of Continents and Oceans, bringing together fossils, matching rock formations, ancient climates, and the remarkable fit of the continents. He had built a case. But the scientific world still wasn't convinced. For years, Wegener lived with the same problem. The evidence kept growing. The acceptance didn't, so he kept searching. The same fossils appeared on continents separated by oceans. Rock formations matched across thousands of kilometers. The Earth seemed to be leaving clues. Wegener believed those clues were telling one story. In 1924, he accepted a professorship in Graz, Austria, where he continued refining his theory and gathering evidence. He had discovered what had happened. What he couldn't yet explain was why. And that missing answer would take another generation of scientists to uncover. By 1930, Alfred Wegener was 50. He had spent decades arguing that the Earth was not the motionless world scientists believed it to be. Now he returned to Greenland for the fourth and final time. This expedition was not about continental drift. A remote research station needed supplies before winter sealed it off. Wegener volunteered to lead the journey. Greenland had once inspired him. Now it became his final challenge. Temperatures could fall below minus 60 degrees Celsius. Winds erased tracks within minutes. In that landscape, one mistake could mean death. On November 1st, Wegener's companions marked his 50th birthday inside a snow-buried tent. There was little food, a little drink, and a brief moment of warmth. It would be his last birthday. Weeks later, Wegener and his Greenlandic companion, Rasmus Wilhelmsen, set out for the main camp. They never arrived. The following spring, searchers found Wegener's body beneath the snow, carefully buried by Wilhelmsen before he disappeared into the wilderness. Wegener's exact cause of death was never certain, but extreme cold and physical exhaustion likely brought his heart to failure. The Arctic had taken the life of the man who had spent years studying it, but it could not take his idea. When Wegener died, many scientists still considered continental drift wrong. For decades, his theory remained on the margins of geology. Then, in the 1950s and 1960s, scientists began looking beneath the oceans. They discovered that the seafloor was not ancient and motionless. New crust was forming, spreading outward from enormous underwater ridges. At last, the missing mechanism had been found. The continents really did move, not by drifting freely through the ocean, as Wegener had imagined, but because they ride on enormous tectonic plates. Wegener had been wrong about the mechanism. He had been right about the Earth. It was not fixed. It was moving. Today, plate tectonics is one of the foundations of modern Earth science, explaining the formation of mountains, earthquakes, volcanoes, and the changing shape of our planet. Wegener never lived to see his idea accepted. Perhaps that is what makes his story remarkable. He did not win because he convinced everyone. He won because he kept searching for evidence when almost everyone else had stopped listening. Sometimes history belongs to the people who are believed first, and sometimes it belongs to the people who are right too early. Alfred Wegener, the man who moved the earth.